All right, so most of you guys have already worked through this first page and half of the second page, but I'm going to go ahead and start at the beginning to make sure that everyone is on the same page. If you are already finished with this portion of the video, just go ahead and fast forward to the beginning of working through the practice problems for remainder theorem, and then on to the checking solutions / zeros and x-intercepts. So as a review, we just want to look here, and we're going to attempt to just do these problems here without a calculator, or without a calculator as much as possible. So 7 into 861, or 861 divided by 7. 7 goes into 8 one time, and we put a 7 down here. 8 minus 7 is 16, or 8 minus 7 is 1. We carry down the 16 and the 1. 7 goes into 16 two times. With 2 left over, we bring down the 1. I apologize. Let's make sure we see what we're doing here. So 17 into 16 would be twice, and that's 14. So we end up with a 2, and a 1 carries down. 7 into 21 would be 3, and 7 times 3 is 21, which gives us a remainder of 0. So our answer is just 123. On the next one here, we're looking to factor and reduce. So in order to factor and reduce, we need to first factor this problem here. So x squared minus x minus 6 becomes x plus 2 times x minus 3, because negative 3 times 2 gives me a negative 6, and since I have the negative x right here, I need the 3 to be the larger number. And then we still have that divided by x plus 2, and the x plus 2 and the x plus 2 cancel each other out, so I'm left with x minus 3 as a final answer. And last but not least, we can do this by long division, which is a bit tedious, so we're only going to do it one time. And what we're looking at is in order to get x cubed, we want an x cubed right down here. What do I need to do to subtract an x cubed? What do I need to do to this x to turn it into an x cubed? And what I would do is multiply it by an x squared. But if I multiply the x by x squared, I also need to multiply the 4 by x squared. So we get a plus 4x squared. And now we're subtracting that entire thing. So we get negative x cubed, which ends up with no x cubes left over. And then 3 minus 4x squared gives me negative x squared. And then I rewrite what I have, 16x plus 10. And now what I'm going to do is look at what would I do to the x to get negative x squared. And I would multiply by a negative x. So I multiply by a negative x squared. I end up with a negative x squared. And then negative x times negative 4 gives me negative 4x. I distribute that negative, and these ones will cancel out. Negative 16x, this is actually a plus because of the negative out here and the negative here. So I get plus 4x, which gives me a negative 12x plus 10. And now I need to look at that x and think about what I would multiply to get to a negative 12x times the x. And so I would get a negative 12. So I get negative 12. Let me rewrite that. Subtracting negative 12x. And then what happens when I multiply a negative 12 times 4? And I get negative 48. And remember that we are distributing that negative in to cancel out. So these 12x cancel out. And up here, sorry, I forgot, we multiplied by a 12, negative 12. Negative and negative for the 48 becomes 10 plus 48, which gives me a remainder of 58. And now we no longer have any x's in our start, which means we have found our remainder. So we have x squared minus x minus 12 with a plus 58 over x plus 4 remainder. So like I said, instead of using long division, we can use what we call synthetic division. And it's used to divide a polynomial by a binomial. So what we're going to do is first look at this bottom term, x plus 2, and set it equal to 0. So we subtract 2, and we get x equals negative 2. And what we're going to do right over here on our notes is we're going to use the coefficients to set up our problem. So the first coefficient is a 5, then negative 6, then negative 28, then negative 2. And I'm going to put that x equals negative 2. I'm going to put that on the outside here, negative 2. And now the first coefficient goes down. When I say goes down, we're going to put a little arrow in a bar. We're going to put that 5 right there. And now what we're going to do is take this negative 2. We're going to multiply by the bottom numbers as we make them. So we multiply with the bottom numbers. And our last number is the remainder. So let's go ahead and see what that looks like. Negative 2 times 5 gives me negative 10. I'm going to put this up here. Maybe we'll use a different color. And negative 6 minus 10 gives me a negative 16. And then I'm going to do negative 2 times negative 16. And I get a positive 32. I'm going to put that here. I'm going to put a little positive right there. Negative 28 plus 32 is going to give me a positive 4. And then negative 2 times 4 is going to give me a negative 8. And negative 2 minus 8 is negative 10. So now what I'm going to do is just take each of these, and I'm going to start with 1 power less than my largest power. So my largest power up here was 3. So instead of a 5x cubed, I'm going to have 5x squared minus 16x plus 4 minus a 10 over x plus 2 as a remainder. And so we can write this in a little bit different of a notation. We start off with our polynomial. Our polynomial is the original problem, the original function. And so that was 5x cubed minus 6x squared minus 28x minus 2. And our x minus k is what we are dividing by. It's what our denominator is. So in this case, sorry, it's x, let's change that color, x plus 2. And then our quotient was our answer. So 5x squared minus 16x plus 4. We're going to leave the remainder off and put the remainder down here at negative 10. Then what we have down here is we can write our answer in the form of f of x equals x minus k times the quotient plus the remainder. So our x minus k was x plus 2. And let's change these colors up. Let's do them in the colors that we have them. X plus 2 times the quotient, which is 5x squared minus 16x plus 4. And last, our remainder, which in this case is a subtract 10. So we're going to do a couple practice problems working through these now. The first one, we have x plus 4 equals 0. Subtract off 4, and we get x equals negative 4. So we put a negative 4 on the outside. And then our first coefficient is 1. Then it's positive 3, negative 16, positive 10. We draw an arrow down for the first one. And now we're going to do negative 4 times 1, which gives us negative 4. And positive 3 minus 4 gives me negative 1. Negative 4 times negative 1 gives me a positive 4. Negative 16 plus 4 gives me negative 12. And negative 4 times negative 12 gives me 48. And 10 plus 48 gives me 58. And that last number is my remainder. So when I rewrite this, I end up with x squared minus x minus 12 plus 58 over x plus 4. So let's look at this next problem here. Now this one's going to end up a little bit tricky. We have x minus 3 equals 0, plus 3, x equals 3. So we have our 3 on the outside. Now the thing about when we're working with synthetic division is that each power needs a place. So we start at x to the 5th, but then we jump from x to the 5th to x to the 3rd, and x squared straight to no variable. So before I can set that up, I have to have a place value for all of these. So the first one is a 2. My power to the 4th is 0. I have 0 times x to the 4th. Then I have negative 10. Then I have negative 19. And then I have 0 times x to the 1st, and then minus 45. Bring the 2 down. 3 times 2 is 6. Positive 6. 0 plus 6 is 6. 3 times 6 is positive 18. Positive 18, negative 10 plus positive 18 gives me a positive 8. 3 times 8 is a positive 24. Negative 19 plus 24 gives me a positive 5. 3 times positive 5 gives me a positive 15. And 15, 0 plus 15 gives me a 15 down here. And 3 times 15 gives me a positive 45, which means I have a remainder of 0, which means that this divides into it perfectly. Our final answer would be 2x to the 4th, starting at the 4th level, plus 6x cubed, plus 8x squared, plus 5x plus 15. I didn't box this one over here. I'll box it real quick as well. And so what we can use this for a little more practically is we can use this to solve and we can use it in many different situations. The first one is with the remainder theorem. And the remainder theorem says that if f of x is divided by x minus k, then the remainder is f of k. So we're going to see what that looks like, but essentially what it's saying is that if we want to substitute a value in and solve, that the remainder is actually our answer when we substitute in a value. Then we can also test solutions or zeros or x-intercepts, which are all kind of synonyms for each other. And with that one, it says that if the remainder is 0, then x equals k is a solution to the function. And so let's work through this problem. We're going to do a solve it by plugging in, and then we're going to look at how much faster it is to use synthetic division. So it says that given 2x cubed plus x squared minus 16x plus 10 equals 0, find f of negative 4. And we're going to first do it by plugging in negative 4. So we have f of negative 4 equals 2 times negative 4 cubed plus 3 times negative 4 squared minus 16 times negative 4 plus 10. So negative 4 cubed gives me negative 64, so I get 2 times negative 64 plus negative 4 squared is positive 16, so I get 3 times 16. And then negative 16 times negative 4 is 64, and that's a positive 64. So now I get 2 times negative 64. And I get negative 128 plus 3 times 16, which is 48, plus 64, plus 10. If I put all of this into my calculator, I end up with f of negative 4 equals negative 6. So that's saying that on that graph where negative 4 is, our y value would be negative 6. So let's look at what happens when we try and do this by synthetic division. So instead of putting the number that we're dividing by on the outside, we're going to put negative 4 on the outside. And I'm going to put the same way that we just did, 2, 3, negative 16, positive 10. Carry that 2 down. Negative 4 times 2 gives me negative 8. Positive 3 minus 8 gives me negative 5. Negative 5 times negative 4 gives me a positive 20. Negative 16 plus 20 gives me a positive 4. And negative 4 times positive 4 gives me a negative 16. Last number becomes our answer. Positive 10 minus 16 gives me a negative 6. So what I can say now is f of negative 4 equals negative 6. A bit faster, a bit cleaner, a bit easier, less areas for mistakes. So now what we're going to do is just work through a couple practice problems using the remainder theorem. So we have negative 2 right here as our problem, or as our number we are going to try and find the solution for. So we put that out front. And then our first coefficient is a 1, positive 5, positive 6. Bring the 1 down, and we get negative 2 times 1, which gives me a negative 2. 5 minus 2 gives me positive 3. Negative 2 times positive 3 gives me negative 6. And positive 6 minus 6 gives me 0. So f of negative 2 equals 0. Looking at the second example here, go ahead and give this one a try on your own. So go ahead and pause the video and give it a try on your own, and then we'll come back together as a group. All right, so now that you've given that problem a try on your own, we put the 2 on the outside, and then we have a 2, negative 3, negative 5, and a positive 4. Bring the 2 down. We get 2 times 2, which becomes positive 4. Negative 3 plus 4 gives me a positive 1. 2 times 1 is a positive 2. Negative 5 plus 2 gives me a negative 3. And 2 times negative 3 gives me a negative 6. Positive 4 minus 6 gives me negative 2. So at f of 2, our answer is negative 2. So now what we're going to do is just check some solutions and see what that looks like. So this has an extra is in it. Let's just scratch that one out. This should say, is negative 5 a 0 of f of x equals x cubed plus 7x squared plus 10x? And if it is a factor, if it is a 0, then when we do synthetic division, our remainder should be 0. So we have a negative 5 on the outside, a 1 for the x cubed, a plus 7 for the x squared, plus 10 for the x, and then a 0 for the number that's over here that is without a variable. So now I'm going to bring down the 1, Negative 5 times 1 gives me negative 5. 7 minus 5 gives me positive 2. Negative 5 times positive 2 gives me negative 10, sorry. Positive 10 minus 10 gives me 0. Negative 5 times 0 is 0. And 0 minus 0 is 0. So we say x equals negative 5 is a 0. And so we can check this out by factoring. If we can factor, we can check it out by factoring. X cubed plus 7x squared plus 10x. All three of these terms have an x, so we can pull that out. I get x squared. I get x times x squared plus 7x plus 10. And then I end up with x, and then an x plus 5, and an x plus 2. Then we look here and we say our zeros would be x equals 0, x equals negative 5, and x equals negative 2. And there's our answer that we found earlier, which shows that negative 5 is in fact a 0. The nice thing about this checking for solutions if it is a 0 is that it will work even if the problem we are looking at is not factorable. So let's look at this next problem here. We have negative 6 on the outside, and we are going to go 4, positive 18, negative 32, and positive 24. Bring the 4 down. Negative 6 times 4 gives me a negative 24. Positive 18 minus 24 gives me a negative 6. Negative 6 times negative 6 gives me a positive 36. Negative 32 plus 36 gives me a positive 4. And negative 6 times 4 gives me a negative 24. And positive 24 minus 24 is a 0. So we can say x equals negative 6 is a solution. And now when we look at this problem and try and factor it, if we try and factor here, we would factor by grouping 4x cubed plus 18x squared minus 32x plus 24. We would look at this and say that all of them have a factor of 2. So I can take 2 out. 2, and then I get, my attempt is going to be to group them like this and end up with the same information. So when I look at this, I end up with 2x cubed plus 9x squared minus 16x plus 12. And the thing is that I can't go any further here, which means that I can't factor this. So this one actually doesn't factor. So I can't check this one by factoring, but I can find that solution using synthetic division. All right, So that is going to be the end of the notes. There's an assignment that goes along with this. We will be looking over it together on Wednesday. But for today, I just want you guys to go ahead and give it a try and do the best that you can. All right. Until next time. See you later.